recently, I think, because previously like CTF are mostly on like hacking or like more on the offensive side, but I think lately they are started to include like more on like defensive side, like forensics into like CTF topics. So yeah, I'm also like play CTF, like not really like good, but sometimes I do join CTF for fun. So if you guys have any sort of like questions related to CTF tips, also you can ask me later during the after the training also, or you can email me. Feel free to just stop me during the training if you have any questions. Okay, so with that, so let's talk about the topic today. We will because this, I think the EDF is a very long topic. I sometimes take like at least 3 days to do this training, but this will be like compressed into 1.5 hours, I think, including the demo and Q&A. So what we're going to learn today is basically like the file system. I think Brother Abubakar have mentioned that he already like taught us about Linux file system. So that's good. That's very important for us before we proceed into like doing forensics. We need to at least understand the basic of file systems on Windows or on any type of system that we want to do forensics. We're going to cover file system and memory forensics only today. I think yeah, I don't have time to cover like everything. There's a lot of like artifacts, but the concept is important. What important is that you guys understand the concept and not just like how to use a tool. This is not a training like how to use a tool, but rather getting to the understanding of the concept of forensics and file analysis. So we will use like open source tools for obvious reason. And yeah, this only this and memory forensics. So in the first chapter, yeah, I'll be going through some of the concept. So this will be like the boring part of the training. And then after that, we go into the demo and I'll show you how to like do the forensics imaging and how to analyze, make a timeline, some tools that can help us with that, and also memory forensics, how to capture memory in a machine, and yeah, how to analyze it. So what is digital forensics? We have to just talk about this. Is the process of like acquiring, analyzing, and presenting relevant data, or sometimes we call it artifacts, forensics artifacts. So acquiring, there's a way for you to acquire data before you analyze it. Like for example, right, if you for malware analysis, if you do it like malware analysis, you can just copy the malware from your host from the affected machine into your like USB drive. That shouldn't be a problem. But when we talk about like digital forensics, we wanted to have a better way of acquiring the data so we don't miss out things, and also because digital forensics is also, DF is also used in like court cases for some of the like criminals activity. You will have to stand in front of a lawyer or legal representative, so you don't want to say that, oh, I copy this file from the host, because that will include a possibility that the data was tampered. So yeah, there's a specific way of acquiring and analyzing the data. Not only limited to like desktop or laptop and mobile. We also, I think, we also have to do like forensics on like, IoT devices, CCTV, everything that have like a basically everything that have like a hard drive or a memory, um, even like a digital camera. Uh, yeah, the main application or the main usage of DF is for criminal and civil investigation. We can also apply it to incident response, like malware investigation. And this is where my major come in. I do more on like incident response or malware analysis, those type of things like IR engineering and stuff. Uh, so yeah, these are like the area of where you can apply digital DF. Mm, basically data recovery. I think this is very commonly, like student always kind of ask me like, hey, they somehow deleted the file, or they have like an old hard drive that are no longer accessible, and they have some images or some pictures inside that hard drive that they wanted to get back. Yeah, so these are like, you can use the technique of like DF to basically recover the data. Yeah, provided that it's not gone absolutely. And then yeah, identity theft. Yeah, this can be proved by doing DF. Basically, if you have the computer, the laptop, or the mobile, or of uh, the accuser, so you can like prove whether they actually do something bad. Uh, and then malware investigation. Yeah, this is like very obvious. Like for example, like a system that was hacked or was installed with malware, you can do like a, yeah, you can prove it uh, by DF, and you can do like analysis on the host to figure out what happened, what was the malware, what the malware did on the host. Is there any sort of like file being stolen, those type of things. And then we also have like the network and internet investigation. So these are, I think, covered. This is not covered today. I think there will be another session for the network, like a network forensics or network analysis. Email investigation, this is so like, common. I don't want to go through all of this. I think it's quite quite some of these are quite like obvious, but it's good to know like the mind getting the mindset of like DF, like where you can apply this and so on. But yeah, if you guys have any question regarding that, feel free to ask. Uh, for like sub branches, like basically we have like four major categories, like, or major type of DF, like disk and file. This is like the most common one. You also have memory forensics, RAM basically, and then mobile and network forensics, which we not cover today. But the concept is the same for mobile forensics and disk forensics. It's the same. Like you acquire the images and then you extract the artifacts and then you analyze it. So it's the same concept for every like disk or memory or mobile. You just need to understand the concept, but you're just dealing with the different type of artifacts or different type of file system, different type of file that you will be end up analyzing. So yeah, in a higher level, like forensics in a nutshell, is like first it's data collection, and then the investigation part. This is where you spend most of the time with. Data collection is quite easy, but it's the most important process of all, because if you collected the wrong data, you will end up with investigating the wrong things. But most of your time will be spent on like investigating or analysis, and then reporting. Yeah, so obviously after you did your analysis, you have to like write a short report in order for you to present to someone else, or in order for you to go to a court cases. Yeah. So data collection, let's talk about data collection. So data collection is basically like acquiring a copy or image of the devices that you want to analyze. So in this case, most of the time it's the hard drive. The hard drive of the that contains the operating system, whether it contains the operating system or not, like USB drive that doesn't contain the OS, but probably there's documents and images. So usually when you collect, like if you're doing data acquisition, you don't like access the host directly. What you will do is you take out the hard drive, and then you have a workstation that you will attach the hard drive to your workstation, and then from your workstation, that's where you pull the data out, or you acquire the image of that hard drive. And yeah, the integrity of that image is very important for like, when doing data collection, because obviously you don't want that data to be tampered during the acquisition. Yeah. And then investigation is the process of where you extract the data from the image. So for example, malware, after you have get the image, right, the the data dump of the hard drive, then you wanted to get the malware from that images, so you extract it. Yeah, you can. We will do the data extraction. It's called data carving or data extraction. So yeah, we will do that later on during the lab part or the demo part. And then you examine the data. You, you do analysis on it. Then you interpret of what data meaning. So there will be like a metadata, for example, like the malware. There will be like the creation time, the execution time. All those are important for you to figure out. Okay, what happened? Like for example, like a malware cases where the user was phished and was tricked into downloading and installing malware. You will be able to see like the browser history of the user, which website did the user go to, and what is the name of the malware file, and what is the malware family and all that. So these are all the answer that you would want to figure out when doing forensics on malware cases. So when you investigate like or doing this analysis, you work on the image, not on the original device. This I have mentioned before. So you don't go to the infected machine and like copy that file out into your USB drive and then do analysis of it. Even though like your analysis may be correct, but because that you may one while you are copying the malware or the like any type of data outside, right, you may tamper with that file. So there's a chance. I mean, there's a chance for you to end up tampering the data, and also you will want to capture like everything. Like you don't want to like, okay, I just want to get the browser history and so on. That's like less likely to be happening. You want to get everything, like all the files, all the system files. And like browser history included. So you would want to capture everything. So you will work on the image and not on the original devices. Reporting. So I don't think I should talk about much about this. Just wanted to say that there is no like a standard way of how you document or writing report for forensics job. There are some guidance that I think you can Google it, like DFIR report example or something, and then they will tell you like what are the segment or what are the point that you need to have when writing like a DF report. Yeah, so okay, important of forensics concept. So once we know that we have to capture the images of the data, right? So let's say you come up with a question like, okay, in a malware host, the host was infected with malware. Which data should I capture first? Is the RAM or the hard drive? So yeah, so these are like the concept will be the same. Like it will be the order of the volatility. So for non-volatile data, like hard drive, you can put it as a lower priority. So RAM is the one that you should capture first, or another like say in a way like volatile data. You can say also like the network uh, capture, right? So PCAP, for example, like your organization doesn't store the PCAP for a very long time. You would store probably like the past 8 hours of network connection. So you would maybe want to look at that first before you go into the hard drive um, and for analysis. Yeah, so I think these are like very basic IT terms, right? You know, IT students should know like volatile uh, data and non-volatile data. Uh, yeah, just to share about like open source tool and commercial tools uh, for DF. Mm, because yeah, if you go to like if you have had a chance to like talk to any sort of like forensic investigator, and yeah, you can ask them like usually you will ask like, oh, what sort of tools do you use and so on. So yeah, they and chances that they might be using those commercial like NKs simply because it's like fastest way to do it and convenient way, convenient. But the concept is same, even though like we don't say that oh open source is like not convenient. I'm not saying that, but it's just like chances that a company, right, when they wanted to do like forensics, of course they will want to spend some money to buy the stuff. So it's more convenient in a way that the UI is probably more fancier, and then the reporting is probably automatically and much better reporting and so on, like much more automated in some of the use cases. But open source too, even though it's like open source, it's still accepted by the community, and it's still like accepted in like court cases. So if you had to go to court and prove that your in analysis is correct, and you say that oh yeah I use this tool, which is like open source tool, it's still accepted. So there's no problem with using open source tools in doing DF. So yeah, let's talk about acquiring forensics images. Okay, before like one of the most like important thing to understand before you do like before you acquire like a hard drive image is that you need to know, you need to have a knowledge of a partition because you might end up pulling like the wrong images or pull the wrong partition. So you know like in hard drive you can create a partitions. Yes, as I mentioned before, so like they when you are acquiring this image for analysis, you would do it on your workstation. So you will take out the hard drive from the infected machine, and then you put it on your workstation. So chances that when you loaded like your images application, like the image capturing application, you would end up looking at your host itself, like your workstation hard drive also as well, and that chances that you have like either USB drive attached to it, so there will be like a lot of this mounted on your workstation, so that can create like some sort of confusion. So this is where like understanding like this partition, understanding like oh how do I want to where which partition should I capture, understand like there's like an MBR, the master boot record inside the hard disk volume. So these are essential skills to have. So I'm not gonna just read this slide, but just wanted to like yeah tell like if you are on Unix, for example, like all the devices are stored under the directory slash def device. Yeah, so all the like volumes are stored there as it's like a file. So you have like a slash device slash SDA or SDB. That's like on Ubuntu. So yeah, every partition is will be treated as like a file on Unix system, and then on like Windows you will have the most common like C drive, D drive, those partition. So yeah, understanding like the basic concept of partition will help. And once you like mount your hard drive into your Unix system, yeah, you need to know like your workstation is most of the time like Unix, right? So you need to know like okay, what will be the effect if I mount this hard drive into my Unix, and how do I find it and all that. So yeah, you need to have those kind of knowledge. Okay, so we talk a little bit about file system. Now we talk. File system is basically like a method for the operating system to store data. So you know that on your hard drive there is a sector, right? On the hard disk there's a sector, and then each sector is like treated different separately of the OS. So each OS, when they try to access a file, or when the way that they remind themselves, like, hey, there's a file in this particular sector. The way that they handle those type of table, or those like caching mechanism, or like encryption, or like how they handle like file deduplication and all that. it's different by operating system. So like Mac, like OS 10 and Windows, the way how they handle file will be different. So some of them may be faster in some way, and some of them will be like much better in some way. Probably like caching is better or faster in some way. Some of them like uh, much optimized when you use SSD, and some of them are like probably the same if you use SSD and you use the non-SSD type of hard disk. Yeah, so let's talk about a little bit about Microsoft Windows file system. So Windows use NTFS file system. So these are like the some of the like common stuff. Is like they have like a maximum volume size of 16 exabyte, and then like a single file you can only put up to 256 terabyte of a file in a single file. So it have like a compression and encrypted file system. So yeah. So NTFS was designed. Let's talk just a little bit about NTFS because we will be. I think NTFS will be the one that you guys handle like the most. More chances that you will be ended up to like do forensics on a Windows right first before you do other. So MFT or the master file table is the heart of NTFS. What is MFT? MFT is basically like it's a file on uh, your Windows. It's not. I think it's not stored as in a file, but stored in a registry. It's basically like an index of a book where it tells you like, okay, if you want to access a file like 1.png or 1.jpg, you need to go to a particular sector. It's like a, like when you have a book, you have like the first pages or the front pages will be the index. So chapter one, which page, chapter two, which page. So these are similar, like MFT store like those information. Um, it also store metadata about the file at some point. Let's say when the file was created and all that. So it have like a good file creation time, file maybe modification time and all that. Yeah. Yeah, so it store the information required to retrieve file from the partition. Uh, so these are the file. I mean, in the if you notice like on your C drive, right, there will be a file that start with this dollar sign and then MFT. Usually, it's in like your C drive or your D drive. So these are the file, the MFT file, or or the link to the registry keys that store all this information. So you sometimes you see like MFT dash MIRR, or you see this as a secure. So those are like the components. Let's talk a little bit about Mac OS. Mac OS is OS 10 is more optimized for SSD. It's have like a what we call hierarchical file system. So yeah, I'm not going to talk too much detail into this. It's just like a different way of how, like, I think Brother Abu Bakar last week have talked about Linux. I think Linux file system. So yeah, it's just like the different way of how sort of like the OS handle this file mapping. Say, yeah, on Linux just called ext4. So yeah, it's good to know, like, let's say you ended up chances that you have to um, you you go on a city app or something, and then they give you like a raw images, and then once you mount it, you notice that, oh, this is like ext4. So you know like what you are dealing with, and you know like what type of file that you will be looking for, what type of data, or what type of uh, like where in the directory is the file, how you want to go around and look for files in Linux system. So that's just how it is. Yeah, we talk a little bit about data states when doing like digital forensics. Uh, so data, uh, this is quite like important to know when you are doing like digital forensics. What is the data states? Like for example, like you are investigating a malware being downloaded into a host, right? And you look into the PCAP file. So these are the data states that where the malware or the data is on the move. So it's like traveling. So the reason like you need to know this is that there's a chance that when you're analyzing like data in transit, it may be truncated, or yeah, you need to keep it in the back of your mind that oh, I am like extracting this malware from network traffic or from PCAP. So there might be a chance that this is not the actual data that being downloaded into the host, because this is just a network. Network shows me this part, and then when you go to the host itself, you get like the data at rest. The data at rest is different than the data in transit. So yeah, this is what this slide is trying to tell you. Like data in use is yeah, is the data in RAM, basically in your memory. So malware being is currently running, that is like data in use. The malware that you retrieve from the hard drive is the yeah, that's the like data at rest. So the difference is that sometimes when you do like memory forensics and you try to pull the malware from memory, and then you go to the hard disk, right? And then you copy the malware, or you extract the malware from the hard drive images, and then you notice that oh, the it's not the same file, it's slightly different. It's like when you run strings, it's like the same, but when you do like integrity check, you check the hashes, it's like not the same. Yeah, so this can be happening because you need to know like oh, because it's data in use, right? During that time there could be some sort of like the malware could be tampering with itself, or it changes. It's not running by itself, it's probably like inject itself into another process. So that's why you didn't get the full uh, the actual the same hashes. So it could also be when you try to extract the data in memory, probably that the way how you extract it's uh, wrong, or there's some yeah, some issue with that. So that could be the problem. So yeah, this is what the slide trying to tell you. Like, it's important to know what type of data that you are currently working on. Yeah, I'm gonna stop a minute on that. If you guys have any sort of questions or doubts, or are we okay to proceed? I no, all good so far. All right, thanks. Yeah, okay. Let's talk about metadata. So every type of data, right, like a file, it contains a metadata. This is example given here is like metadata about a person. Yeah, metadata about a person can be like his location, his name, his ID card, his hair color. But for like malware, it can be like the file creation time, the owner of the file, so the file size. Those are like considered metadata. So knowing like what a metadata can tell you is very essential for, and knowing the differences about what the metadata can is a like very essential knowledge to have when you do like for example like log analysis. Like okay, let's say the situation here is that you are on a server and you are investigating that the server was being hacked via web application. So yeah, what type of logs do you want to acquire from the server, and what type of artifacts that you want to get? So these are like you can derive this answer by knowing like the metadata of the file. Like, okay, I'm going to probably get the prefetch file. I'm going to get like the uh, web access logs, and then from the web access logs, they probably like multiple web access logs. So which web access logs that should I acquire and all that. So you need to know like probably I want to get the web access log during that time of the attack, and how you get the web access log during that time of the attack. You probably have to look at the metadata of the file creation of that access log. So yeah, let's talk about this is the much more fun part where we're going to talk about the image acquisition. Image acquisition is basically like a process of you acquiring a sound copy of the image of the device to analyze. Sound copy or sound means that we are able to verify the image is the exact copy. So you know that I think you guys know how to do like hashes, right? How to do like check like MD5 hash or SHA-1. So these are like integrity checks. You can use it to verify whether like, let's say you are capturing your hard disk images. So you can do like the hashes of your hard drive, like all the whole like the image, and then you can check like once you have the copy, you can check like, oh, it's whether it's the same and all that. So yeah, these are good to some of the like acquisition tools. They already have this built in, so you don't need to manually run like hashes check. Just the integrity check will be done automatically by the tools to help you. Yeah, it's a bit by bit copy of the media. Uh, yeah, it's basically a copy of the raw disk. So if you have like a 500 gig of hard drive, then the copy or the, the image will also be the same size. It's also like a 500 gig. Yeah, the media must not be altered in any way, because this will sort of like circumvent your forensics result of your forensics analysis. Yeah, so we're gonna have to talk about like how you do like forensics image acquisition. So yeah, so you can do it by removing the hard drive, or you can do it by not removing the hard drive. So uh, this is just basically like if you have a Kali Linux, you can take the hard disk of um, the the device that you wanted to do at forensics on it. So like, let's say there's a USB drive, easier. So you can just attach that USB drive to your workstation or to your Kali Linux. But if you wanted to do like a image dumping of a laptop, right? And then let's say you don't want to like open the screwdriver on your laptop. You don't want to open the screw on your laptop. Uh, then what you can do is like use Kali Linux in a like boot in the USB drive, and then you just point your boot into that Kali Linux, and then from the command line from the terminal, you can do the data dump of the hard disk itself. So basically, you tell the laptop, okay, boot from this USB drive, which is your Kali Linux is installed in your USB drive, and then you from your Kali Linux you can directly access, or you can make these images of that particular laptop drive. But you need to somehow have a way for you to store that images. So let's say you have your uh, bootable disk or bootable drive, Kali Linux, and then when you plug in, then the images or the tool that you are using to acquire will ask you like, hey, where should I save this? So if it's like a 500 gig worth of hard drive, you need to have like a 500 gig worth of space for you to be able to save that forensic image. So the image format, so images will end up as a file. It become like a file, but the file is the image file. So it can be, it has like multiple format, raw, AFF, and uh, EWF. So these are the format. uh, I think AFF and EWF is those like usually used by the commercial tools. Raw is the one that we will be using, I think, yeah, most of the time. So in like CTF, right, usually you will be given these images. You will be given like raw images of a USB drive, or you will be given uh, uh, the hard disk dump, the full like hard disk drive dump. So it will be in raw format usually. So it will tell you like this is the raw format or something. Yeah, this is basically the duplicate of all the sector in the hard disk partition. So you're not only copying the file, so you're only copying everything, like even like an empty file, truncated file, or the empty sector, all that file is copied. Yeah, we going to, for demo, like, or for just knowledge base, we just going to use this tool called DD, data dump. Okay. So on Linux, how you wanted to identify the drive, or what are the drive that you wanted to dump, right? What are the file that you want to do the analysis on, or you want to basically acquire the image on. Um, so on Linux is yeah, it's identifies under the slash dev or device directory. So yeah. Um, here. Let me actually just show you in my Linux. So yeah, you can use the this tool to figure out. Where's my VM? Okay. This size okay. Or you can you see my like or cannot make it bigger or zoom in. Okay. Yeah. So on Linux or on Kali, you can use like command df minus h for you to figure out like what are the hard drive that is available, or what are the hard drive that is mounted on your Unix machine, or your on your Kali. So in this example, I have this is the OS hard disk, which is most of the time is SDA1. SDA is the device, or the hard drive, and then the one is the partition. So if I have like a multiple partition on this, I would be seeing like def SDA2, def SDA3. So I only have this, and then you can use like fdisk utility, fdisk minus L command, and then this will tell you like, okay, I have 80 gig of space, and I have this much sector. So sector is like uh, one sector is like consider 512 bytes of the hard drive. So yeah, you have this, and you have like this identifier. So let's say I mounted, or I put in the USB drive into this Linux, right? Then when I rerun the command fdisk, I should be seeing like def sdb, and then if I mount again another one, I should see like def sdc. So this will be like added into that. So and then the size you can see here. So like in like how what I mentioned before, right? If you wanted to, this is, let's say this is your workstation and you want to do a data dump on like external drive or the malicious drive, whatever, your target drive, then you would need to like do a, you need to mount it, and then you, once you have you see this, like they will be like def SDB or something, then you can basically do the image on that using the DD tool. So yeah, let's talk a little bit about the yeah, this. Okay. Yeah, okay. So this is example of the. Let me just paste it in the chat. Yeah, this is example of how you use like the DD or DC3 DD to do image dump or like, yeah, copying of the image hard drive. You will need to basically give the IF or the input file and then the output file where you want to save it. So input file in this, in like previous example, right? Let's say let's say I have a USB drive. After I've mounted the drive, I will see def SDB under here. So that will be my input file. So I would do something like DC3DD IF equals to /def/SDB, and then output file where I want to store it. Maybe I want to store it in my desktop or my some other places or another external drive. And then hashing is just specify like the hash technique that you want the data to you want DD to validate against. Usually we just use like SHA-512 or something. Yeah, you can read. I gave the links. You can read about like how to use that. You can also set like I think you can set. Let's say you don't want to dump the whole disk, right? You just wanted to get like a certain sector that like the images that I want to extract from a USB drive. I know the sector of that image, so you can use like a command to skip some sector. So you, let's say the sector that you want is like on the 300, right? So you can skip from 0 to 299, and then um, start to get or start to like dump from that particular sector, like that sector 300. Okay. Okay. Any questions about imaging? So I'm gonna stop a bit. Any question like about doing imaging? Can I get some feedback? Is it like too easy or too hard or like just okay?
Assalamualaikum.
Yeah, walaikum salam.
I think it's okay. And actually, I have a question.
Yeah, sure.
Okay, so this DDC something
Yeah.
DD3 CDDD,
Uh,
like what is the difference of this DC3DD and the actual DD? Like, does it have any difference, or it's just
it's no different actually. It's just some commands are much what you call this are much user friendly. Like the options here, yeah, you can use DD actually. I think the difference is like some of the options here. Like say you wanted to do the quite advanced one, or the like you wanted to skip some sector or something. I think on DD, right, the just that this particular command, it will be something like I forgot what it is. It's something that is like non self explanatory, like it will be like IS or something. But this one is like it just tell you like it's ice skip. So
Yeah, I
yeah,
understand.
yeah.
I
So it
see. I see.
yeah, it's more like it's more just that friendlier command line.
Simplicity, basically.
Yeah, simplicity. Yeah, correct.
Got it.
Yep. Yeah, that's a good question. Cool. Okay. Can proceed. So okay, let's do data carving. Okay, let's proceed. So yeah, the next step, like after you have uh, run your imaging, right? If you capture your image, now you can start like doing data carving or data recovery to say. So you need to know sort of like the knowledge that you need to have is like when the file is deleted, right? The what the operating system do is that it remove the let's say the directory entry, or you just remove it from the file table. Basically, it just tell the OS that, oh, forget about this file. But the file in physically, or to say, it it is still available on the disk. They just mark as free. So the since in here it says that the allocated blocks uh, just mark as free whenever you delete a file. So let's say you just delete a file, PNG, JPEG file, right? It's still there on your hard disk. So maybe after like a year or so, you have used that hard disk. You have used it for a long time. Then that particular space that was previously used to store that JPEG file will be taken over. So yeah, these are the concept. So you can like recover the file if it's still like new, or chances that most of the time chances that you can still retrieve back the file if the deleted is not like too long or something. Yeah. So this is like the knowledge that you need to have when you're doing like forensics analysis. You need to know like, okay, the file is deleted, but how long is it while ago that it's been deleted, since that you can try to like do a strings on the images, or do like searches, like how you would want to search like on a file, search for like the magic header file. Let's say you are looking for JPEG file, so there will be like the magic header JPEG in that images, and then there will be like the file footer, so in the image, so you can like extract the file back, you can extract the file again. uh, so yeah, this technique is called data carving. Data carving is like, it's basically like pulling all the files on a hard disk image. Hang on a second. Okay. So so a data carving tool, right? We go back to this. Data carving tool understands or it stores a whole lot of file magic header or magic number. Magic number is basically a header in a file. Like if you open it with some hex editor tools, you can see. So magic number is basically like the header of a file, and then it will end with the NOF marker. So any file will contain that. You can see some example here. I think there will be an example. Okay, let's look at. Ensure. Let's look at JPEG file format in order for us to understand like data carving. Okay, here. Okay, here. Okay, so example like in a this is a JPEG file binary. If you open it with like any hex editor, you will see that it have the header of like FF D8FF or FFD8. So in your this image file, this particular how data will be stored in that image file, right? So if you have like a JPEG in that hard drive, it will be stored as in this particular format. It, you can see it. So you can basically, if you know the header or the marker, then you can extract it using this like method. You can just find FFD8. I wanted to find like JPEG, and then you can see the the marker or the where the file ends. Uh, yeah, so you can like give a read about this like file format. So every type of file there is like a simple file format like exe file have like the mg header. I think you might be familiar with that. So yeah, so this is how like we do like extraction from images. We just find like the marker of the file that we wanted to know, and then we extract it. So you can do this like manually using like on Linux. You can use like xxd command to like extract like from which offset to which offset, and then you can get the file from like the disk dump or from raw disk. But you can also use some tools like will help you automatically like carve the data out. So for this example, I'm gonna just use data from here. So this like, website contains its images, but I think it's a very small image. Uh, we can just use this for demo. So I already have this download. Uh, okay. Okay. So I have downloaded this file called l0 underscore graphic.dd. So dd is the data dump that we did that before. So this is a very small it's only like 62 meg of data dump, and it's also I think it's have multiple session like L0 to L4, but I only download the first one, so L0. It's okay. I just wanted to like carve some data out from this image. So this image size is 62 meg, very small, good for demo. So for like there's a lot of tools that you can use to automatically carve data out, right? You can use like tools on Linux, on Kali. You can use like the Sluice Kit. You can use Foremost, Scalpel, Photorec, or Bug Extractor. So these tools, I think most of it is available on Kali. So these are like open source. So what it does is that the concept is similar. It store like it remember like okay, if I want to detect like JPEG, these are the magic header and the end of file. So you can give like a data disk or a data dump, the DD output, and then it can extract the file back. So if you have like you deleted some file on your USB drive, you can do a data dump and then use this tool to like carve out all your available images or file from it. So for demo, I'm just gonna use Foremost. I have this installed Foremost. I forgot what's the oops. Foremost minus H. Okay. So oh okay. gonna rerun that again. Done. So once I have run like foremost and give the input of that DT, so uh, I will it will create a folder here named output, and you can see here there's a GIF, JPEG, and PNG, and then it will write a quick report called audit.txt. This will tell you like the file that it was able to extract. So I got 3 files that was extracted from that DD data dump, JPEG, GIF, and PNG file. So yeah. So if you use if you wanted to check whether like a file or these images contain that particular file, right? You can use like the strings command just to grab like the PNG, or yeah, you can see here that they are PNG. There's some like reference to. It's not clear. Uh, yeah, you can use like yeah, you can use like strings or XXD to figure out. Okay, there's a. I can see here that there's a PNG header with the IHDR. So yeah, this is uh, this is definitely like a PNG file. Magic header looks like a yeah, PNG file magic header. So yeah, I can then I can like uh, proceed to do extraction of this. I'm gonna give you a link that it's a very good write up that I found regarding manual data carving. So I'm gonna put it there and give it a read. I'm gonna take a break for 5 minutes, and while I'm doing that, you guys can read this file carving. It's a very old blog, 2013, but the concept is good. So you guys can like give it a read, like a 5 minutes. I think it should be enough. So we're gonna like have a break for 5 minutes. While doing that, you guys can probably check this out, read it, let me know your thoughts or questions about it. So yeah, it it's not using foremost. It's just a manual carving of the data. So you can see like how the guy uses DD to um, dump the data out by I think he's skipping some sector. So he's giving like a count of 10983, which is the sector uh, of where that PNG file resides. So yeah, it's a byte. I think there's some skip here. It says skip how much records in that particular sector. So you, the dump will start from there. So you can manually carve the data. So yeah, uh, give it a read. I'm gonna take a 5 minutes break. While I'm doing that, yeah, you guys feel free to ask questions as well. Anyone have any questions regarding like data carving? No, all good. Thanks. Okay. Okay. I think we can continue now. Let's start again. Uh, okay. Let's just talk lastly about manual carving. So, yeah, I'm gonna share my screen again. So manual carving. Yeah, this is like the process of how you would do manual carving on these images. So first you have to identify like the type of file that you want to extract or you want to carve. This example is like JPEG or PNG. So once you have identified that or you know that is the file that you want to extract, then you just have to locate the header and the footer in which sector or in which bytes yes, the file is resides. And then yeah, you can use a command like xxd or dd to extract the file. And yeah, after you have determined like the file content and all that, so you can just extract that particular bytes out. So I mentioned this before, like in our demo, we use Foremost, but it's all like similar and the concept is the same. That's it for like data carving. Now we will move on into autopsy. So autopsy, so in data carving, if you notice that we only talk about like a hard disk drive, which may contain like just images, or you wanted to cover up images, you want to do like data recovery. So it's pretty easy. But let's say you are given this image of Windows OS. Inside there, there's a Windows operating system. You will deal with tons of uh, tons of files. They will be like the system32 files. There will be registry keys all over the place. There will be system file. There will be the user file. So uh, it's very hard to like analyze if you run like Foremost. If you run like Foremost, and then you will get like a lot of exe file, like, and you don't know like where this file is. Is this like system32 file or is this like a program file? So it's not convenient to use like Foremost to extract files to carve files from Windows images, the image or the hard disk that contain Windows operating system in it. So autopsy is or the sleuth kit, it provide like some sort of case management, timelining. It provide like a nice UI for you to see, and then you can do like a timeline. So you can do like malware analysis and like timeline analysis. So yeah, this is the features like you can And of course, you need to analyze the image. You can do like file activity, when the file was first created, file last created, file metadata. You can extract the timestamp of the file being created. You can do like user analysis. So let's say your machine was hacked and someone created like a bad user or like, yeah. So you can yeah, basically do analysis on that. So let me, okay, oh, I need to show the demo for, oh no, for autopsy. Uh, so at the end of this lecture, I will be giving you guys so-called like assignment or quiz, a quiz. So I will give you guys a DD drive, and I will just ask you guys to write some reports of like what's happening. There will be a set of questions that you need to answer, and yeah, whoever get like the sort of like the best technical answer and the best write up will get some prize. So just yeah, I'm just gonna talk about more later about that. So let's yeah, it's okay, whatever. Okay, autopsy. Yeah. I recommend you to use like, autopsy on Windows. If you don't have Windows machine, you can still install it on Linux. It's just that the Linux version, the UI is a bit wonky. I want to say it's a bit like, yeah, some of the like, yeah, the UI is just not uh, not as nice as the one on Windows. But you can still use it, so it's fine. But if you don't have like a Windows machine, so this is uh, this is how autopsy looks like. Uh, so let's say you once you have created like this image from that contains OS on it, like Linux or Windows, you can like create a case here, and then you can add like your data sources. You can add the data sources here means like the raw images, that file, and then it will show you like much nicer data, and it will help you to interpret the data in a way so you don't have to like manually like use formos and then try to make interpretation of data. It just uh, tell you everything, and including like the artifacts, like the registry keys and all that. Oh no, that's take a while. Mm, I have more. Um, I have more sample of like USB drive. Yeah, more sample of a USB drive data. If you guys want to play with like data carving or want to play with, you can also mount that or add that this drive into your autopsy to play around. See that if you want to carve data out, you want to extract some data or do like analysis. It's slow. Okay. Okay. Mm. Yeah. So here, like if I have loaded this data source, this sample data source into my autopsy, and then you can see here that it will directly tell you like uh, it will directly tell you like is there's if there's like a deleted file, and then you can browse your file, as in like you are browsing your like your C drive, right? So here you can see like data sources. That's the name of the hard disk, SC hard 001, and then you can see like it's a NTFS file system. Uh, so as you can see like all the my documents file. So it's just like browsing your own computer. So you can see all the program file. Yeah. So this is, and it gives you some interpretation of like the data artifact, um, operating system information. These are all derived from the registry keys. It can tell you like yeah, the USB device attached, uh, web cookies. So
Hello, Assalamu alaikum.
yeah, welcome salam.
I think I cannot see your screen. Am I alone?
Oh, is it? Is it?
Yeah, I can't see your screen. If someone can see, please tell me. Maybe the problem is from me. Okay, let me reload the page then.
Okay, okay, okay. You guys are seeing my Windows screen now, right? The Windows, the autopsy screen.
Yes, yes.
Okay, okay,
Okay, now I can see.
okay, okay. Yeah, sorry. Yeah, all right. Yeah, all good. Okay, yeah. So these are the like the file you can access it, and then let's say you want to extract the file. So it gives you all these like interpretation of the files. So this web history, usually like web history is derived from your index.dat file in under your Internet Explorer folder. But Autopsy basically it passed the file by itself, and then it represent the data in this format. So you don't have to go and extract the index.dat file. You don't have to do that. So if you click on the index.dat file, so you can see here that these are the web history, right? So the web history is stored in like this document and setting, Mr. Evil temporary internet file, IE5 index.dat. So these are the file index.dat, which is the temporary internet file, which is the web history. But you don't need to manually go and take that file out and then do analysis on it, because Autopsy already like pass the file and give you this view. So it's a nice view. So if you wanted to think there's a way, if you really want to extract the file, yeah, this is the file. You can carve out this file. This is the hex dump of the index.dat. I think for some file like exe file, let's see file in the recycle bin. Yeah, there's some file in the recycle bin, right? So you can extract file here. So you can right click on the file, extract it. So this is what it's similarly how it do. We're doing like file carving before, right? So you can just extract the file and then you can save it. So yeah, it's very convenient to use this for. Yeah, you can do like timelining. Yeah, as I mentioned before, this training isn't about like using tools. It's more like understanding the concept. So you can figure out how to use this by playing around with it. So I will give you this. I will give you this forensic image. It's also not mine. I found it from a university. So you can use it for like learning purpose. We just you can copy this and play around with it. So this is how like basically we do like forensics analysis. We try to figure out, okay, if we saw like a binary file that was executed, and then we can check like the modified time when it was created and all that. So you can see like this document and setting was created. This is like a very old image because I couldn't find any images that are newer and having like a very small disk space. Like all the newer system have like uh, big hard drive, and I don't want to run it on my VM. So ideally, you would need like some good operating system if you want to analyze like a big disk, right? Like 500 gig, right? So imagine like autopsy have to pass like 500 gigabyte of file. So that may takes a lot of time and yeah, use a lot of your processor. So I use like a, yeah, for the demo sake of demo, we use like old because it's quite small. And this one also, I think a few hundred meg. So, but the concept is same. We just wanted to learn about the concept, right? Uh, okay. So, yeah, any questions so far about like this forensics? Or you guys, we can move to like memory forensics. That is okay. No question. Okay, let's move into memory forensics. So, start. Okay, let's quickly talk about memory forensic. So memory forensic is similar to this forensic. The concept is very similar. You can dump the memory images and then it's in raw format. Um, yeah. So in all operating system, there's a concept of virtual memory. What virtual memory is that it uses a part of your hard drive in order for it to back up the existing memory. I give you an example is that you have 8 gig RAM, RAM, right? So let's say you are running your Chrome and then you're running some other application, you're playing games and whatnot. And if the RAM have to allocate uh, each of the application with a certain space, right? Let's say 2 gig. Then if you have 8 gig, you can only run like 4 application, and then after that your RAM will stuck. So these are uh, what the virtual VM or virtual memory technology came in, and it will tell the application as in that you have the whole space of RAM. You can use like there's like infinite uh, value of memory that you can use. It just like it's just kind of like uh, a, a management that it puts in the middle between the application and the uh, and the memory on the and the RAM, the application and the RAM. There is a um, mapping in the middle. So this mapping is the one sort of responsible to manage the memory and say that okay, uh, if I'm no longer using certain part of the memory, I'm gonna put it into a disk called pagefile.sys. This is a file on your hard drive on the hard disk, so that it kind of manage it. So when an application requests for a RAM that you wanted to use, then only that management will return or will map it back to your RAM. So RAM is faster than hard drive, right? But the point is that you have some sort of like mapping to your hard drive. So your hard drive is like, let's say you have, so virtually like if you have like 4 gig of RAM, you the application may see it as like it contain like 16 gig of RAM because of the usage of the this virtual memory technology. It take part of your hard disk to tell the application that yeah you can use up to 16 gig of RAM. So that's why like you can run a lot of application with just quite a very small RAM. Yeah. So memory images similar to like how we use this forensic. We also need to acquire memory. So you can use
we dump from the hard drive or from anything else?
Mm, that's a good question. We usually like hashes the use hash technique to validate. So before you acquire the uh, let's say this image, right? Before you actually acquire this image, you mounted this image in like dev SDB or something, and then on Linux, I think you can run like MD5 or SHA-1 dev SDB, and then that will tell you like the hashes of that hard drive, and then you do the image like DD, and then you check again the initial hash that you get. It should be the same.
I see, I see.
Uh,
Okay.
yeah. Okay. But yeah, I can also like you guys don't need to ask me about um, this DFIR, but yeah, let's say related to CTF maybe. If you guys have any questions related to CTF, you can also ask. Okay, we have one. How long it takes to solve CTF question regarding digital forensics? Mm, so I think usually in all CTF, right, they will be like a level of questions that they will ask in every topic. For example, like DFIR, maybe you have like the first level, which is very simple. They give you like memory image, or they give you a log file, and then they just ask you what are the IP address that the file connected to it. That one you can probably get the answer in like 15 minutes, 20 minutes, depends on like your tools that available, or your currently like sometimes luck as well. But yeah, they will be like those type of level where the first questions or the first two three questions is just very straightforward, very direct questions, and then it will followed by much like a mid level questions where you are asked to it's not straightforward. You are asked to dump data from the extract data or carve data out from the artifacts, and then yeah, and then the next level would be like those tricky questions, like you need to figure out what's uh, the interview or the questionnaire the person who write that question is thinking. So those are the most difficult questions. So I would say the third level is like probably we're gonna take you hours to do it, but the second one, if you are lucky as well, it takes like probably less than an hour or something. Yeah, but definitely like try to answer the first level question first, even in all topics, like not only DF, like all topics like network, web app. Try to aim for the lower fruit first, like low level, the easier, and then go to the medium and hard. Yeah, that's just my my thoughts on this question.
Right. Thank you for the answer.
Yeah.
I have a question.
Yeah.
Okay, so is there like any relationship between penetration testing and then digital forensics?
Uh yeah, the relationship is that the DF investigator wants to catch the penetration tester, and the penetration tester wants to avoid DF as much as possible. That's the that's the general like uh, relationship. They will always find like the pen tester. They always find like a way to hide or to avoid being detected or avoid being found. And us as a digital forensic investigator, we always like also find a way to like make sure they are not they are not they are catch they are found. There are some like attacker that I've seen before really sort of know. So you can tell like the level of the knowledge of the pen tester when you are given the set of the forensic artifact, right? You know that, oh, this guy, the command that he executed, he didn't even like try to encode a PowerShell command or something. He just ran like a blank malicious command, like download directly, and then the URL is there. He didn't try even to try to like encode or some way to avoid being detected. So those are these are my thoughts on this.
Okay, so I get it. And the last question, probably the last question, is it's like in the future,
Mhm.
uh, let's assume I choose to be a digital forensics. Um, so like, what are my job scope, like a typical job scope?
Ah, this is a good question. So there are two type of digital forensics investigator. One is the one I described earlier, like try catches the bad guy. Those type of forensic investigator. The other part of forensic investigator is more like the law enforcer. You work with like police, you work with the legal entity, you work with like human resources. These are more like they try to find evidence related to cases such as maybe like acquire child pornography file on a hard disk, or someone worked for a company and he raged about the company and he wanted to like do revenge before he was fired or something, and then he kind of like leaked company information and all that. So you they are these are the DF that works on the forensics side of things, where they have to prove this type of criminal activities, and they have to these are the guy who like have to go to the court, be be suspicious, be like the what you call it, the witness. So the other part I think is the one uh, like the SOC analyst type of DF like me, where we security operation. We work in a security operation or in antivirus company where we find evidence in digital forensics and then we write detection on like antivirus platform. We don't deal with like those people who like download illegal stuff or install illegal stuff. We don't do that. But we can do it. Another is also consultancy. You can also go for consultancy route. So there will be like the DF where legal entity. There will be the DF will do like security operation, and then there will be the DF will do like more on consultancy. The consultancy is less technical, but you need to have this knowledge where entity like company like university will go to you and they will ask for like just DF advice. They won't ask you to do it. You don't actually do hands on, but you more like advising them. Okay, they wanted to set up a team, right? So you advise them. Okay, these are the team. How many people you need? How many type of what are your tools that you need, and so on. Yeah, hope I answer the question. So there are like I would say like there are three parts of like job scope you can go to. Is that
All right.
kind of like yeah?
Yeah, yeah, it does answer the question indeed. Someone is asking what is your favorite place to write up, especially for the forensic stuff?
Read write ups.
Yeah, yeah.
I think he means like read. Is it like a technical report or is it the write ups? Like a
From
training, like a training.
no, from what I understand from his question, he's asking like right now, let's assume he want to learn forensic. So what is
Okay,
like the
okay.
best place to get the write ups? Because he's talking about reading the write ups.
Okay. Oh, YouTube. I would say, yeah, I don't have. I'm not the kind that have like a specific. There are some trainings that I would recommend, but it's not free. So for free stuff, I I think you should try YouTube. Is the best, but I can recommend like a channel called IPSEC. You can check that YouTube channel. IPSEC. These have a lot of OSCP related stuff and both like pen test and digital forensics. Uh, yeah, YouTube IPSEC. Uh, check it out. Yeah, they have a lot of like good explanation about things. But in terms of like writing write ups, there's recently I think there's no much. Reddit is probably another thing, another place you can try to check. I don't remember the group, but there's a Reddit session. Yeah, so YouTube and Reddit. There's a Reddit for SOC. Check for like Reddit uh, security operations and digital forensics. Yeah, these are where people like ask questions uh, about like digital forensics, and then you can read the discussion at the bottom. So these are also nice place to find. Yeah, CTF time.
All right, thank you so much. I think we gonna end the session here. Thank you for your time and for your honest advices and answering the question. And please don't forget to do the quiz and then email him to the email. It is already in the chat box. If you didn't copy it yet, I will share it in the group as well. So I guess
Oh yeah.
you don't really have to copy it for now.
Okay. Yeah. That's the question number five. Actually, it was truncated. So yeah. Okay. Yeah. Feel free to like email me even regarding any sort of questions. Uh, yeah. Try to answer it. Uh, yeah. Hopefully it was useful. And thank you.
Yeah, it is actually very, very useful. Thank you for your time. Um, so this comes to the end of the event. Brother Hakim, if you're here, please can you come and do the closing prayer?
بسم الله الرحمن الرحيم سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك بسم الله الرحمن الرحيم والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر آمين.
Thank you so much, Brother Hakim, and thank you everybody. Please don't forget to submit the attendance form. And I think that's all for today. Thank you so much. thank everyone for joining the meeting.